Module 5, Risk Assessment and Safe Systems of Work Intermediate Level HSE Practitioner Program. Every serious workplace accident begins long before the injury happens, before the collapse, before the fire, before the fall, before the explosion. There were warning signs, a hazard ignored, a shortcut accepted, a risk underestimated, a procedure was skipped. And that is why professional HSE practice exists. At KAYHAB 17, HSE Global Safety Leader, we train safety professionals to identify danger before incidents happen. Because the best HSE officers are not emergency responders alone. They are risk controllers. They see hazards early. They challenge unsafe systems. They protect workers before their lives are changed forever. Slow pace. Strong emphasis. Today, we move beyond beginner awareness into practical safety management. This module focuses on one of the most important responsibilities in construction and oil and gas operations: risk assessment and safe systems of work. Background visuals. Crane lifting operation. Permit office. HSE officer conducting inspection. Workers at toolbox talk. Heat stress monitoring. Scaffold inspection. Ambient sound. Light industrial site atmosphere. Radio communication. Soft cinematic percussion. Learning outcomes. By the end of this training, you should be able to identify advanced workplace hazards, recognize changing risks during live operations, participate in HIRA, JSA, and JHA preparation, understand severity, likelihood, and residual risk, assist in developing safe systems of work, understand method statements and RAMs, apply the hierarchy of control correctly, deliver effective toolbox talks professionally, and most importantly, you should begin thinking like a practical HSE professional, not just a worker following rules, but somebody capable of supporting site safety decisions. That transition is what makes employers take you seriously. 1. Advanced hazard identification and risk recognition. Professional HSE officers do not just look, they observe. Many new safety personnel make one dangerous mistake. They only look for obvious hazards. But on real projects, the most dangerous hazards are often hidden. A missing guardrail is easy to notice. Fatigue is not. Gas accumulation inside a confined space is not. Heat stress build gradually during a 12-hour shift is not. This is why professional hazard identification requires observation, anticipation, and critical thinking, not just eyesight. Visible hazards, open trench, rotating machinery, oil spill, fire, hidden hazards, gas exposure, fatigue, heat stress, pressure buildup, noise damage. Real site example, excavation collapse. Let us use a real scenario. A contractor begins excavation beside an existing roadway. The visible hazard is obvious, an open trench, but the hidden hazards include underground electrical cables, soil instability, vibration from nearby vehicles, and water seepage after rainfall. The excavation initially appears safe, then conditions change. Rain falls overnight. The soil weakens. By morning, the risk increases significantly. This is called a changing hazard, and this is why HSE officers continuously reassess risk throughout the shift, not only at the beginning. Pause after conditions change. Let the seriousness settle. Static vs. changing hazards. Static hazards remain relatively stable. Examples: permanent machinery, fixed electrical systems, permanent stair openings. Changing hazards evolve during operations. Examples: where the change is SIMOPS activities, crane movement, traffic patterns, worker fatigue during overtime. In oil and gas shutdowns, changing hazards are extremely common because hundreds of tasks happen simultaneously. This increases interaction risk. Static hazards, stable and predictable. Changing hazards, dynamic and evolving. Examples: animation. Sunny weather turning to storm, crane entering active area, excavation filling with water. SIMOPS, simultaneous operations. One of the most important operational risks in construction and oil and gas is SIMOPS. Simultaneous operations. This means multiple activities happening together within the same work area. Example: welding beside fuel transfer, excavation beside underground utilities, painting near hot work crane, lifting above scaffold crews. Each task may already have hazards individually, but combined together, the risk multiplies. This is why permit coordination meetings exist. This is why work sequencing matters. This is why communication failures kill people. Remember this for your interview. Professional HSE officers do not assess tasks individually alone. They assess interaction between tasks. That is advanced risk thinking. Heat stress and human factors. Now let us discuss one of the most underestimated hazards in Africa and the GCC. Heat stress. In countries like Nigeria, Qatar, UAE, and Saudi Arabia, workers may operate in temperatures above 40 degrees Celsius. Heat stress effects. Judgment, concentration, coordination, reaction speed. A worker suffering heat exhaustion may miss hazards, forget procedures, make poor decisions, become aggressive or confused. This creates secondary hazards. Because human performance declines. This area is called human factors in IOSH and NEBOSH systems. Human factors include fatigue, stress, distraction, complacency, overconfidence, time pressure. Many incidents happen because workers rush to finish tasks quickly, not because they lack knowledge. Human factors. Fatigue, stress, time pressure, distraction, overconfidence. Human behavior changes risk. Unsafe acts vs. unsafe conditions. Professional investigations examine both unsafe conditions and unsafe acts together. Unsafe condition. A dangerous workplace situation. Examples. Damaged scaffold, broken ladder, missing barricade. Unsafe act. Unsafe human behavior. Examples. Climbing without harness, running on site, bypassing lockout procedures. Most accidents involve both categories. Example. Worker fall from height. Unsafe condition. Incomplete edge protection. Unsafe act. Worker disconnected lanyard. Good HSE officers identify both together, not separately. Practical activity. Mock site walkthrough. Now let us practice hazard recognition. You are now the HSE officer. The camera will move through a live construction site. Pause the video and identify. Unsafe conditions, unsafe acts, environmental hazards. High-risk activities, human factor indicators. Observe carefully, because observation skills separates experienced safety personnel from beginners. Mock site walkthrough. Find. Unsafe acts. Unsafe conditions. White heavy checkmark, environmental hazards. White heavy checkmark, human factor risks. Visuals include worker using grinder without a face shield. Scaffold missing toe, board, fuel drum beside welding worker showing fatigue, water accumulation near electrical cable. Section 2. Risk assessment. HIRA, JSA, JAW. Risk assessment is the foundation of professional safety management. Every serious project depends on effective risk assessment. Without proper risk assessment, permits fail, controls fail, planning fails, workers get injured. Risk assessment is not paperwork. It is decision-making. NEBOSH defines risk assessment as a systematic process of identifying hazards, evaluating risks, and implementing suitable controls. Simple meaning. What can hurt people? How bad can it become? How do we stop it? HIRA process explained. HIRA means hazard identification and risk assessment. The process normally follows 7 steps. Step 1. Identify the activity. Example. Scaffold erection. Step 2. Identify hazards. Examples. Fall from height, falling objects, scaffold collapse. Step 3. Identify consequences. Examples. Injury, fatality, property damage. Step 4. Assess likelihood. How likely is the event? Step 5. Assess severity. How serious could the outcome become? Step 6. Determine risk rating. Low, medium, high, or extreme. Step 7. Apply controls and review residual risk. HIRA flow. Activity. Hazard. Consequence. Likelihood. Severity. Controls. Residual risk. Severity versus likelihood. One of the most common interview questions for HSE positions is, what is the difference between severity and likelihood? Severity means how serious the outcome could be. Likelihood means how probable the event is. Example, a hammer falling from 20 meters. Severity, extremely high. Likelihood, depends on controls. If exclusion zones exist, the likelihood reduces. This is why both factors matter together. Risk matrix explained. The risk matrix combines severity and likelihood to determine the overall risk level. Low severity plus low likelihood equals low risk. High severity plus high likelihood equals extreme risk. Professional companies use these ratings to decide whether work can continue, whether additional controls are required, and whether management approval is needed. Extreme risk activities usually require senior authorization, PTW detailed supervision, emergency planning. 5x5 risk matrix graphic. Green equals low, yellow equals medium, orange equals high, red equals extreme. Animated example. Worker grinding metal near flammable material. Residual risk. Residual risk means a remaining risk after controls are applied. Risk rarely becomes zero. Example. Workers use harnesses during work at height. Risk reduces significantly, but anchor points can fail. Workers can misuse equipment. Rescue delays can happen. Residual risk still exists. That is why supervision remains necessary even after controls are implemented. JSA and JO, Task Breakdown Method. Job safety analysis and job hazard analysis are practical methods used heavily on-site. The principle is simple. Break the task into steps. Then identify hazards, controls for each step. Example. Task. Changing the electrical motor. Step 1. Isolate power. Hazard. Electric shock. Control. Loto. Step 2. Remove motor bolts. Hazard. Drop tools. Control. Tool lanyards and exclusion zone. This method forces teams to think before acting. And thinking before acting prevents incidents. Live practical risk assessment template. Now, let us complete a real example together. Activity. Scaffold erection. Hazard. Fall from height. Possible consequence. Fatal injury. Existing controls. Competent scaffolders. Additional controls. Full body harness. Double lanyard. Exclusion zone. Scaffold inspection tag. Toolbox talk. Initial risk. Extreme. Residual risk. Medium. This is exactly what HSE officers review during planning meetings. Live HIRA template. Columns. Activity hazard consequence, existing controls, additional controls, initial risk, residual risk. Realistic controls. One major mistake beginners make is writing weak controls. Examples of weak controls. Be careful. Avoid accidents. Work safely. These are not professional controls. Strong controls are specific and measurable. Examples. Install barricades. Conduct gas testing every 2 hours. Use certified lifting slings. Verify isolation before maintenance. Assign a fire watch during welding. Specific controls show competence. This is what employers want to see. Section 3. Method statements and safe work procedures. The risk assessment identifies danger. The method statement explains safe execution. A method statement explains exactly how work will be completed safely. It is a structured work procedure. Professional method statements usually contain scope of work, sequence of work, manpower requirements, equipment requirements, PPE requirements, emergency arrangements, responsibilities. This document connects planning to execution. Sequence of work. Sequence matters. An incorrect sequence creates incidents. Example. Confined space entry. Correct sequence. Isolation, lockout, gas testing, ventilation, permit approval entry. The wrong sequence can kill workers. This is why method statements are reviewed carefully before high-risk work begins. RAMs and PTW connection. Many companies combine risk assessment and method statement into one package called RAMs. RAMs support the permit to work system. Permit issuers review RAMs before approving high-risk tasks. This ensures hazards are identified, controls are implemented, and workers understand procedures. Emergency plans exist. Practical activity, method statement demo. Now, let us prepare a simple method statement for working at height. Step 1. Define activity. Roof maintenance. Step 2. List manpower. Supervisor, technician, and standby personnel. Step 3. Equipment. Scaffold harness, lifeline, radio communication. Step 4. PPE. Helmet, gloves, safety boots, harness. Step 5. Emergency arrangements. Rescue team. First aider. Emergency contact procedure. This is practical site planning, not theory. Method statement structure. White heavy checkmark activity. White heavy checkmark work sequence. White heavy checkmark equipment. White heavy checkmark PPE. White heavy checkmark emergency plan. Section 4. Hierarchy of control. The best control removes danger before workers depend on PPE. The hierarchy of control helps us select the most effective controls first. The 5 levels are elimination, substitution, engineering controls, administrative controls, PPE. Hierarchy of control pyramid. Top, elimination. Bottom, PPE. Worked example, cutting metal with grinder. Let us use a real example. Cutting metal using a grinder. Elimination. Can prefabricated materials remove the need for cutting entirely? Substitution. Use safer cutting equipment with lower spark generation. Engineering controls. Spark guards, ventilation systems, noise barriers. Administrative controls. Training permit system. Supervision. Safe work procedures. PPE. Face shield, gloves, hearing protection, flame-resistant clothing. Notice something important. PPE is the last line of defense. Because PPE depends on human behavior. Workers may forget PPE, wear it incorrectly, remove it during discomfort. That is why NEBOSH identifies PPE as the weakest control. Good HSE officers always control hazards at source first. Interview tip. Remember this for interviews. If asked, what is the strongest control? The answer is elimination, not PPE. That single answer immediately shows a stronger HSE understanding. Section 5. Toolbox Talk Leadership. Communication prevents incidents before work begins. A toolbox talk is a short, safety discussion conducted before work starts. Its purpose is to communicate hazards, explain controls, confirm understanding, and improve worker awareness. Bad toolbox talks fail because they are too long, too technical, repetitive, poorly delivered. Workers disconnect quickly when talks sound like punishment instead of communication. How to deliver effective toolbox talks. Good toolbox talks should focus on one topic, use simple language, relate to actual site conditions, encourage worker participation, include questions, confirm understanding, practical delivery tips, face workers clearly, speak confidently, avoid reading directly from paper, and use real examples. Keep duration short. Good toolbox talks feel like conversations, not lectures. Mini toolbox talk demo, heat stress. Good morning, team. Today's toolbox talk is about heat stress. Weather conditions are extremely hot today, and heat stress can affect concentration, reaction time, and judgment. Symptoms include dizziness, heavy sweating, weakness, headache, and confusion. Drink water regularly, even if you do not feel thirsty. Use shaded rest areas during breaks. If you notice any coworker looking weak or disoriented, report immediately. Heat stress can become fatal if ignored. Does anyone know the first sign of heat exhaustion? Pause for engagement. Excellent. Work safely, everyone. Toolbox talk checklist. White heavy checkmark short. White heavy checkmark relevant. White heavy checkmark interactive. White heavy checkmark clear. White heavy checkmark recorded. Conclusion and final quiz. Today you learned advanced hazard identification, changing hazards and SIMAPs, human factors, HIRA and risk assessment, risk matrices, residual risk, JSA and JHA method statements, hierarchy of control, toolbox talk leadership. These are professional operational HSE skills, not beginner awareness. These are the exact competences companies expect from HSE assistants, junior safety officers, safety supervisors, site HSE coordinators. You are now learning how to support work planning professionally. That is employability. Final quick quiz. Question 1. What is the difference between severity and likelihood? Question 2. Why is PPE considered the weakest control? Question 3. What is residual risk? Question 4. What does SIMAPs mean? Question 5. Why must workers understand method statements? Question 6. What is the strongest level in the hierarchy of control? Pause after each question. Final closing message. Safety management is not about stopping work. It is about controlling work professionally. Every permit, every risk assessment, every toolbox talk, every inspection exists for one reason: to ensure workers return home safely. At KAYHAB 17, HSE Global Safety Leader, we believe competent HSE professionals are built through observation, discipline, planning, and continuous learning. Keep developing your skills. Keep asking questions. Keep challenging unsafe behavior. Because a strong HSE culture begins with competent people, and competence begins with training. See you in Module 6.